previous video, we factorized by taking out highest common factors. In this video, we are going to explore a different method of factorizing, which is the difference of two squares. In this video, we are going to see visually what are we doing when we are factorizing in this way. So in other words, what are we doing when we are taking two squares and we are writing it as the product of its factors, which is what factorization is. And then in the video after this, we're going to do a bunch of examples, easier ones, and then more complicated ones. So that is an important video. Let's jump in and look visually. What are we doing when we are factorizing difference of two squares? What does it mean, difference of two squares? Well, difference of two squares means that there would be a minus in between two terms where both of them are perfect squares. Now let's go make it visual. Let's look at what we've got over there. If we represent x squared visually over there, if we've got a square with a side length of x, then it means that that side length will also be x. All of the side lengths will be x, and then the area of the square would be represented by x squared. So the area of that square is represented by x squared. And then if we subtract y squared, well, we can represent y squared as a square, the area of a square with the side length of y, and then that one will obviously also be y because it's a square, and then the area will be represented as y squared. So let's see how we can write that as a product of factors, because we just broke up x squared as a product of its factors, and we broke up y squared as a product of its factors. Now, let's see what we can do in order to factorize and to put all of that together. Well, I'm going to take that square and I'm going to subtract it from x squared. So if I subtract it, I'm just going to make a cutout of that exact same area out of that. So in other words, what am I doing? I am subtracting that orange area from the blue area. Some of you might say it's green because the blue area is x squared. I am subtracting y squared. We are doing some geometry thinking with this. So if we want to get the answer for x squared minus y squared, we need to see what area are we left with. What area does that blue part represent? We can do that. We can go divide these into familiar shapes that we know. We can create rectangle 1 and we can create rectangle 2, and we can write those rectangles, areas, and we can add it together, and that will give me the total blue area. How are we going to do that? Well, we know that that length over there would be x, and we know that that whole length over there is x. We know that this length over here is y, and that one will be y. So for rectangle number 1, if I go write down that area, it would be x times, well, that side length is x. That's why I'm getting the length for that rectangle. But now I need the length for this side over there. What is that? This whole side length is x, and that one is y. So surely that little one that we're looking for over there must be x minus y. So I'm multiplying the length of that rectangle by the breadth of the rectangle, which gives me that area. For rectangle 2, I need those dimensions. Well, I know that that side length over there is y. Now we need this side length over here. Well, we know that that whole side length over there is x. And we know that that from there to there is y. So surely that little piece must be x subtract y. X subtract y. And now we need to add those two areas together. So the area of rectangle 1 plus the area of rectangle 2 gives me the total area for that blue part that's left over when I say x squared minus y squared. So our knowledge from the previous video, if we take out our common factor over there, we'll be left with x minus y, and then left over in the first term, we've got x, and left over in the second term, we've got y. And there we are done. We factorized it. We wrote it as a product of its factors. All right, so let me just create a little bit of space there. So I'm going to write down what we found over there. X squared minus y squared gives us two brackets, and then x minus y, x plus y. So the brackets are almost identical. It's just for the signs in between, right? For the next one, let's create something else there. I know the squares are exactly the same, but let's create something else. Let's say this one is a square with side length of p, and this is a square with a side length of 2. That means that this square, that side length will also be p, and this side length will also be 2. So what are we dealing with? We've got p squared and we've got 4. So let's see if we want to say p squared and we are subtracting 4 and we want to factorize that. We want to write it as a product of its factors. Let's go ahead and do that. I'm going to do what I did with the other one. So I'm going to bring this square and I'm going to make a cut out because I'm subtracting them, right? So I'm subtracting the area of that one. So we need to subtract that. We will be left with the green area. P squared minus 4 represents that green area. So we need to divide it into shapes that we know that we can find the area for. So we're going to find the area of rectangle 1 and we're going to find the area for rectangle 2 and then we're going to add them together. So for rectangle 1, the length will be p, and that breadth over there will be p minus 2, because those side lengths there were 2, right? So p minus 2. And then for rectangle number 2, well, we know that that side length over there would be 2. But what would be that side length over there? We know that this whole one will be p, and we know that that one will be 2. So surely it is represented by p minus 2. Now we need to add those two. We're adding the area of rectangle 1 and rectangle 2. Note from our previous video, taking out a common bracket. If we take out that common bracket, we are left in the first term with p, and we are left in the second term with 2. And there we factorized it. We wrote that as a product of its factors. So multiply that out. If we FOIL it out, we are going to get to the exact same expression. So let me just write it over there as we did with the previous one, and then we compare. This one gave us p minus 2, and then p plus 2. Now note, just like we saw with the first one, over there, the brackets are basically identical. It's just the signs that are different. So can you see that there we had x squared, and it just landed up being x and x. And there we got y squared, and just y, and then plus and minus. And with this one, we had p squared, and then it's just p and p. And there we had 4, which can be represented as 2 squared. And then we just had 2 and 2. So there's definitely a pattern forming there that will work every single time. And what is that pattern? Let's do the next example and apply this. So let's say we've got that example over there. We need to factorize the following. Well, how do we immediately know that it's difference of 2 squares? Because we can represent y squared as a square that has side lengths y and y. And we can represent 16 as a square that has a side length of 4 and 4. My area there would be y squared. My area there would be 16. So both those terms must be perfect squares, and they must be separated by a minus. Then we know that it will break up into 2 sets of brackets, where we will have the square root of the first term, the square root of the second term, and then 1 plus and 1 minus. And that's it. And we are going to apply that shortcut in the next video. Some of you like knowing where it comes from, and some of you are just like, I don't even know why you're showing me this. And that's okay. I just also want to bring this to your attention. You know how sometimes somebody does something really quick and you're like, how did they even do that? Like a math calculation in their head or whatever. Now, if we look at this sum, the instruction is that we are supposed to simplify. So we know with this one, sure, we know that we can FOIL this one out. That would be perfectly fine if we are supposed to simplify. But if I look at the pattern over there, then I can see that, wait a minute, these 2 brackets are basically the same. The only difference is 1 plus and 1 minus. So that would be the result of dots. And then I know that the expression that would have been factorized to look like that would have been y squared minus 16. Because it would be the first term in each bracket squared, and it would be the second term in each term squared. Now let's test that. I'm going to FOIL it out, which takes a little bit longer, perfectly fine. but we're going to get to the same answer. Y times y, y squared, take away 4y, plus 4y, and then subtract 16. So there I'm foiling it out. Do you see that those two cancel out? And we are left with the same solution. Just a time saver. All right. Well, I'll see you in the next video where we're going to do examples on factorizing using the difference of two squares.